Hi everyone. In today's session, we are going to see important technical questions that will be mainly asked in interviews and gate examination. Let us discuss those questions in detail. They have given the question like this. They have given the character array character C of 100, 100 means that there are 1000 locations reserved. And they said, what is the address of C of 40, 50? Address of C of 40, 50. Now, we can find out the answer for this directly by using the equation. To know the address of any element of two-dimensional array like this, ampersand of A of ij will be given as the base address plus I into number of columns into j into the number of bytes an element is going to take. This is the equation. Now, by using this equation, we can find out address of C of 40, 50 will be given as the base address. See, at the time of asking the question, they will provide the base address. In this question, they have given that the base address is 0, right? Now you substitute the base address 0 here. I value how much? 40. This is the I value into number of columns you have to take. Number of columns here from the declaration of an array you take 1000. You replace 100 into j. What is the j value here? 50. This is I value and this is j value. You substitute j value 50 into c number of bytes and character is going to take. The character is going to take only 1 byte of memory. Now the final answer we are going to get 4050. This is the answer. Address of C of 4050 is 4050 if the base address is 0. Now the equation base address plus I into NC into J into C is only valid when the index, that means whenever we say character of C of 100, 100, here the starting index is 0 and the ending index is 99. Here also starting index is 0 and we are reaching 99. When the starting index is 0, this is the equation we have to use. But in some cases, they are going to explicitly specify the starting index. Assume that they are giving the starting index 3 and ending index is 99, and another dimension. For the second dimension, the starting index is 4 and the ending one is 99. In this case, the starting index is not 0. In that case, this equation can be modified as the base address. It is given as the base address plus you write I change it to I minus lower bound 1, lower bound 1 into NC into J will be changed as J minus lower bound 2. Okay, so this is the equation we have to use into C. This is the equation we have to use when the starting index is not 0. So lower bound 1 is the starting index 3, lower bound 2 is the starting index 4 for the second dimension. These are the two principles to find out the general formula to find out the address of an element of two-dimensional array. Now, we are going to see how the equation or the formula is derived. We are going to derive the formula from this example. Let us take an example. Integer a of 3, 3. I am taking a two-dimensional integer array a of 3, 3. See, we know a two-dimensional array is nothing but the collection of one-dimensional arrays. The memory representation of this can be given like this. Just I am taking an array representation like this. For understanding purpose, here I am taking 3 rows and 3 columns. But actually, after first one-dimensional array in continuation, second one-dimensional array is stored. After that, third one-dimensional array is stored. So everything is stored in the form of row. But for my convenience, I have written like this. This is first one-dimensional array. Here I am writing this is first one-dimensional array, and this is the second one-dimensional array, and this is third one-dimensional array. It is the collection of, this is the collection of 3 one-dimensional arrays. Let us assume the address of the first one-dimensional array is 100. When the address of the whole first one-dimensional array is 100, then what would be the address of the first element? 100. And here I'm taking it as 104 and this is 108. Let us assume. Why 104, 108? We know that an integer is going to take 4 bytes of memory. After 108, next we are moving to this place and it is 112. 112 is what? 112 is nothing but the address of the second one dimensional array, right? This is first one dimensional array and this is second one dimensional array. Then what is the address of the first element of second one dimensional? 112 and this is 116 and this is 120, right? This is the first one dimensional array, right? And this is the second one dimensional array, right? And this is third one dimensional. Now what is the value here? I'm taking assume that 124. Then the address of the first element of three-dimensional array also becomes 124 and assume that 128 this is 132. Here I'm writing some addresses, right? Now after writing this, what I'm going to do is let us find the address of A of 22. What would be the address of A of 22? Okay. Now from this I can write one thing, that assume that A of 2 is nothing but B. Now this equation can be written as ampersand of B of 2, right? This can be written as ampersand of B of 2. In the previous discussion of pointers, we have written that B of square brackets of 2 is given as star of B plus 2, right? The same thing I can rewrite it as ampersand of star of B can be written as star of A plus 2. And here I am writing plus 2 as it is. Just I am writing this. In place of B, I have substituted A of 2. A of 2 again written as star of A plus 2. After this, what I'm going to do is, let us write again ampersand of star of. Here what you write? Star of. What is A? A value how much here? Now A represents the name of the two-dimensional array. The name of the two-dimensional array A is 100, means it is pointing to this. Meaning here is 100 is not the address of the first element. The array name A100 represents the address of the first whole one-dimensional array. Okay, what is that? 100 plus 2 and here plus 2. Now the important thing you should remember here is ampersand of star of 100. What is mean by this plus 2? Plus 2 indicates that from this first one-dimensional array, you move further two locations like this. Means we are going to cross first one-dimensional array and second one-dimensional array and we are moving to third one-dimensional array. Means that plus 2 in the sense we have crossed this element, this element, this element, this element, this element, this element. How many elements we have crossed? 6 elements. Okay. What is the column size of each and every one-dimensional array? 3. 6 elements. How we get this 6 elements? This can be given as 2 into 3. Okay. 2, so you see we have 2 rows here. Each 2 rows is given as 2 here. Each row consists of 3 elements. The same 2 will be given as 2 into 3 and each element is going to take 4 bytes of memory. So that's why this 2 I'm rewriting it as like this, 2 into 3 into 4. Okay. After this we are writing plus 2 here. This is plus 2. What is mean by plus 2 here? We have reached to third one-dimensional array. That means we reached to 124. From this 124, we are moving two locations again. From this 124, again we are moving two locations further like this. Okay, means we are indirectly reaching to 132. So two locations we are moving from here to here means 2 into, you write two location. 2 is nothing but number of location, 2 elements, okay. But each element is going to take how much memory? 2 into 4. This 2 will be written as 2 into 4. That means this first 2 is represented as 2 into 3 into 4. That means 6 elements, 64 is 24, right? And here from this 2 elements, 2 into each element is going to take 4 bytes. Now, once again, we are rewriting the statement. So here what we have written here, This I'm writing ampersand of star of star of, what we are writing, ampersand of star of star of 100 plus 2. Here I'm writing 100 plus 2, and here I'm writing plus 2. Okay. See, same thing I'm going to rewrite it as ampersand of star of star of. Here what I'm going to write here is 100 plus this. We have written that 2 into 3 into 4. Okay, plus 2 we are writing as it is. Ampersand of star of, here I'm writing star. See, this what we are going to get is 1000 plus, sorry, 100 plus 24. Just I'm writing like this for convenient. This will be given as ampersand of star of, this is star of 124 plus 2. This implies ampersand of star of 124, again 124 only. 124 plus 2. 124 plus 2. See, ampersand of star of 124. What star of 124 means? Value at 124, address at 124, value at 124, again 124. Here, this 124, what I'm going to do is, I'm going to keep the same thing like this. That means 100 plus 2 into 3 into 4. I'm writing the same, this 124 like this. Plus, this 2, I can write it as 2 into 4, right? Try to understand this. Now, this will get cancelled. Now, what we are going to get is 100 plus 2 into 3 into 4 plus 2 into 4. That in the sense 100, you take 4 common, 2 into 3 plus 2 we are getting, and you take into 4 is a common. So, this leads to 100 plus 2 into 3 plus 2 into 4. That means this is base address plus 2 is nothing but I into 3 means number of columns NC plus 2 means J value, okay, into 4 is the size of an integer C. So here the equation is this for the integer variable. This is the way of deriving the equation to find out the address of an element of two-dimensional array. With this, I'm going to close the session. Thank you very much for watching.